Here, let's put some work on the board first. Cartesian vectors. I'm starting with homework for a change because this beginning homework is optional. I'm writing it on the board for you guys though, because if you looked at what just happened, guys, hello? There you go. If you looked at what just happened on the last two examples, and if you said to yourself, I didn't really get what happened there, okay, look at those questions and make sure you can do it, especially the substitution stuff. Try a few questions yourselves to make sure you can knock those out of the park. You know the way this calculus course works, I expect that when you're doing a question, you know, you can be a master of the skills, right? So if I have to use elimination or distance between lines later on, the thought should be that you can do it with no thought, okay? And if you're not there yet, that's try to do that, okay? There isn't a lot of work for helpers. There's not not a lot of homework tonight. This is like the first day of the lesson. So you remember how the unit goes like this, and then it does this. Is anyone here gone on rugby trip? Okay. Our test is for. You're not gone on the rugby trip. Okay. Okay. When? I can live with that. Okay. What I was wanting to was closer to March break. So the Tuesday.
Girls rugby teams going to Ireland.
Yeah. So I think the test is, guys, please. What's probably going to happen is the next test will probably be the Tuesday after March break. I think is when it's going to be. So I will give you guys your assignment for the March break. It won't be like miles and miles and miles. Okay. So, but I'll give it to you again like usual, like the Wednesday before the March break, so you can work on it then. And then Sunday night you can hopefully cram. And you'll do nothing during the week. I'm a teenager. It was once too. I know you'll do nothing during March break. Okay, right. But then the Sunday night before it can start up again then, and then the Tuesday will be due. That's probably what's going to happen. All right, so here we go. Cartesian vectors. We're going to say Rene Descartes. Okay, so here we go. We're going to talk, please go here. We're going to talk about the Cartesian vectors. Rene Descartes was the creator of this. Where this came from was this. He was sitting, he's a French, can I talk please? He was a French mathematician, and he was sitting in his bed one day in the summer, and he saw a fly buzzing around the ceiling. Frustrated like anyone else when there's a fly in this house. So he was a mathematician, so he thought, you know what I could actually do, if I consider the top corner of my bedroom to be 0, 0, 0, I could find the location of the fly in 3 space. So base 2 is x coordinate, how far it's going to be this way, is y coordinate, how far it's going to be this way, and then a z coordinate for how high it's going to be up and down. So he's the guy, if you ever wondered, the xy is called the Cartesian plane, that's what it's called, like the xy plane that we've done all the graphing on, that's where it comes from. So I'm going to put down bracket, fly made x, y, z axis. So the point is this, all it's relative to an origin. And that's what happens in this case. These vectors are different because instead of being like a vector of 28 kilometers, okay, or something like that, the idea is it's going to be starting at 0, 0, 0. All of these vectors are going to be starting from the origin. That's the difference in this case. So instead of dealing with just general vectors, these are going to be vectors that we can draw on an x, y, and then eventually z plane as well. Okay? So we're going to say here, we're going to say let vector u be any vector with endpoints Q and R. We're going to say we identify QR as a Cartesian vector because its endpoints can be defined using Cartesian coordinates. Okay, we're going to say the position vector A comma B is a vector from the origin to point. So I apologize once again. The first lesson is always terminology. I'm sorry about that. Okay, that's the way this course goes. Okay. All right. So today and tomorrow probably a lot of terminology for stuff. Okay, so this is sort of a big idea. All the difference in this unit is, instead of dealing with just vectors floating around, like on ramps and pulleys and stuff like that, what it's going to be is we're going back to math, going back to x and y. That's going back to, okay? So a Cartesian vector, a position vector, if there's a square brackets, what it means is the end point is A and B and the starting point is 0, 0. And if you remember how a vector goes, you can move it all over the place, and we'll deal with that here in a sec. Okay, questions about that logic? So far, so good? No? Yes? Good? Okay, here we go. More notes. The unit vectors. I and J. Are the foundation of algebra with Cartesian vectors. Sorry for the notes here again. So vector I is going to be 1, 0. Vector J is going to be 0, 1. So therefore, vector A, B is going to be A times I plus B times J. So basically what you're going to do is here you're able to, and this is a nice thing for us in math class, and this is why this is nice, and I love this unit, because all of a sudden we can change vectors from arrows on paper to algebra. And for me as a math teacher, I like that. I like algebra. All right. So the idea is all we're doing is we're basically, what are we doing there? What do we do to our vectors here? Substitute a little bit, but there's another word I want you to say. We're doing components. That's basically what we did there. Right, okay. So all we're doing is there, right, you're changing, I is going to be what we call the unit vector once again. So it's going to be the y component, basically, of the equation. The j is going to be the x component of the equation. That's the idea. Okay, the logic of this before we keep going here?
Is that always?
Always. I is always x, j is always y. We'll get to k, it'll be z in a few days, okay? But k will be z when we get to z. Okay, let's keep going now. Yeah, I is the same as x, yeah, the same. So I is the same as x and j is the same. What's that? Z is going to be z. Z is going to be k, eventually. Okay, but we'll get to that in the next few days. I want to get all the foundational stuff done in 2 dimensions, and then we'll just extend it in the lesson in the 3rd dimension. So here we go. We're going to say using similar reasoning. If I were to say we use mi, what would mi equal as far as you bring it into a vector? What would mi be, please? Yeah, go ahead. M0, very good. The same way, nj, somebody else please, what does nj equal, please? Sorry? Go ahead. 0, n. Okay, so let's use some more logic here. If I do mi plus nj. What's mi plus nj going to be then? What's mi plus nj going to be? Mn long. We'll write it out here. So m comma 0 plus 0 comma n. I'm going to be mean and write it like this for the one time only. Okay, now Joey, you're right. You can skip there very, very quickly going to that, but I just want to lay it out there to make sure life is good. Okay, so all I'm saying, what we showed there is that any vector can be written. Thus, any vector can be written as a sum of its horizontal and vertical components. And this really shouldn't shock you. Because we just did it like for a whole week there at the end of the last chapter. We just prove it here after this. All right, so far so good. I'm going to hit pause and give you a second to rest your hand for a second before you do notes. I'm sorry, the first day or two is awful because I got all this background stuff.